Hey guys, it's Mrs. Conway. So in between me being gone a lot and some of you guys having some absences, I thought I should go over some of the more important vocabulary for our proofs unit, which is, I've been calling it Unit 3 because it's our third unit. And then I'm also going to go over the 3 methods of proof in a different video. So, let's take a look at the vocabulary that's going to be really important for our proofs test. So if you go to Agile Mind right now, there's this assignment called Vertical Angles Notes Required, which we're looking at 6th period right now, but you can see just by looking at this wheel that not a lot of people actually made it through these notes. So what I'm going to do is I'm not going to take you through all the notes because some of it is more direct than others. I would like for you to go through these notes if you haven't done that yet. But the really important stuff is all going to be in our summary here. So I'm going to go to the summary. And what you should do right now, if you haven't done it yet, is you should get out your math notebook and you should write these important vocabulary words down as I go through them so that you have them to study. So we talked a little bit about conjectures and postulates. That is not going to be necessarily on your test, but just be aware. Conjecture is something we're thinking. A postulate is something that we've all agreed is true. And so we started with the segment addition postulate and the angle addition postulate. So the segment addition postulate just states the obvious that we know, that if you add 2 small segments together, you're going to get the big segment that they make up together if they're next to each other. And the way we state that is if Z is between A and B, then AZ plus ZB equals AB. So you should write that down in your math notebook. Hit pause so you have time. And the angle addition postulate says the same thing but about angles. If we have 2 angles that are next to each other, if we add them together, it gives us the whole big angle. If B is in the interior, that means it's inside AXD, then the measure of angle AXB plus the measure of angle AXD equals the measure of angle AXD. Fancy way of saying if we add the angles together, we get the big one. So if you don't have those written down yet, you should hit pause and copy them into your math notebook. So the next thing is these properties of equality. So the properties of equality are something that you've been using basically since you've been doing algebra. And the properties of equality are the addition property, that's saying that I can add the same number on both sides of an equation. The subtraction property says I can subtract the same number on the same side of an equation. Multiplication property, I can multiply it on the same side. And division property is saying I can divide the same number on both sides of an equation. So you've been doing these in algebra, but you didn't necessarily say that's what you were doing. Now, if you do that in a proof, you have to actually say, you know, I divided both sides by 2 because of the division property of equality. And this right here, if that was confusing where it says C equals 0, this is just, or say C is not equal to 0, it's just saying that obviously we can't divide by 0. And then we've got the substitution property, which is if 2 things are equal, we can now substitute them for each other, which is something we're going to use a lot when we do proofs. So this is a really important property right here. The reflexive property, we haven't used it much this unit, but it will come up, particularly when we're proving triangles are congruent. It's just saying that something is always equal to itself. The symmetric property is like that you can flip an equation around. That one, you will have to occasionally use it if you end up with, you get your final answer, you get B equals A, but you're trying to prove that A equals B. You do actually have to state the reflexive property or the symmetric property if you flip those around. And then the transitive property, the substitution property and the transitive property are very closely related because transitive property is saying if A equals B, and B equals C, then A must equal C. It's basically saying we can not, because you technically would be using the substitution property twice if you were doing transitive property. So it's a way we can kind of skip steps and only have to say one step, transitive property instead of doing substitution property twice. So you should write these down if you haven't written them down yet. Hit pause and go ahead and make sure you have them copied in your math notebook. All right, the linear pair theorem is another big one. We proved this in class, but you might not have been here when we did it. If you weren't, you should go to the Agile Mind slides and look through them and look at the proof. But it's the idea that if two angles make a linear pair, then they are also going to be supplementary, which seems really obvious because if two angles make a line, then they would be 180 degrees because lines are 180 degrees. But it is something that you can prove, and it's a pretty simple proof because I just basically proved it, right? Since a line is 180 degrees, if two angles make a line, two angles add up to the same thing that is also 180, then they are going to be 180. The common segment theorem we used a lot, we practiced with a lot. It's the idea that if you have sort of overlapping segments and the tail ends are congruent, then the original segments were congruent, or vice versa. So this is saying if AC equals BD, so the two big segments are congruent, then the little leftover bits, AB and CD, would also have to be congruent. Vice versa, if AB is the same as CD, then AC must be the same as BD. And this is actually where that reflexive property comes in, because BC will always be congruent to itself. So here we've got the common angle theorem. It's the same idea, but with angles. If angles 1 and 3 are congruent, then angle AXC would be congruent to angle BXD. If angle AXC is congruent to angle BXD, then angles 1 and 3 would be congruent. They're stating it as the measures are the same. That just makes it a little easier because we can use equal signs instead of congruent signs. But to say that the measure of angle 1 equals the measure of angle C3 is the same thing as saying angles 1 and 3 are congruent. So I tend to use them interchangeably. Okay, the vertical angle theorem. This is proved earlier. If you go up in this assignment and do it earlier, it's proved. But it's just really important that you know the vertical angle theorem. We're going to use it a lot in the next unit. So if you don't know it, it's going to make the next unit harder. So the vertical angle theorem is saying if we have two lines that intersect, they're going to have vertical angles which are congruent. And when I say vertical angles, I mean angles that are across from each other. So here you can see that this angle and this angle, AEB and DEC, are congruent because they're across from each other, which is what a vertical angle means. The other pair of vertical angles here would be AED and BEC. These two are also congruent and vertical. So these are the vocabulary words that's going to be really important for you to know, or not necessarily vocabulary, theorems, postulates that you're going to need to use to prove stuff on the proof test. So make sure you have them written down. Make sure you understand what they mean. If you go to Delta Math, you're going to find that there is some practice for this stuff. So let me show you. If you're looking at Delta Math, you're going to have these blue assignments are the current ones for this unit. I went ahead and made them due on the last day. Yeah, so tomorrow, which is supposed to be the test day, which is Thursday. We're probably going to bump that out to November 5th. But if you do look at these assignments, practice 2 is just going to have you practicing using the segment addition postulate. So you'll need to draw a picture of this, and it says, you know, we've got HJ, which is going to be our big segment, and then HJ is 8, HI is 2, find IJ. I is on the line segment, that means it's in between H and J. So we know H, the big segment's 8, one of the other little segments is 2, So we're going to have to subtract to find ij, which will be 6. So those ones I've gone over in class. There's also a help video that was made by Delta that you can do. So these are just practice using the segment and angle addition theorems and postulates, and then some review from first unit that's going to practice with your markers and midpoints and stuff like that. This is important practice. And then the other practice we have here is the vertical angle stuff. And this last one is going to be vertical angle terminology with equations. So again, you're probably going to want to draw a picture of this. So this one's talking about supplementary angles. We've got A and B are supplementary. So that means they would add up to 180. So you would write an equation, 5x plus 25 plus 3x plus 19 equals 180. Then you would solve for x and use that to find out what B is by plugging it in for x. If you have vertical angles, they're going to be congruent. So you would write that the two equations the two expressions are equal to each other. So it's just practice using those vocabulary. And again, there's some videos for that. So this is what I would do right now. I would copy those vocabulary down, and then I would do these Delta Math assignments to just help practice using the vocabulary. That's the kind of stuff you can practice on your own. Then when we're in class, you can practice the proofs, and then I can be there to help you with it. So get to work on that Delta Math, and then if you still want some more practice with the proofs, watch my proof video after you've had some time to practice the Delta Math. Good luck!